I am a tech ed teacher. I teach seventh grade in West Hempstead Secondary School. We're a very, very small school district right outside of New York City. I used to teach in New York City, and we were having issues where Maker Ed was sort of, I had done a lot with Maker Ed. I had a Maker Ed cohort. We were doing really wonderful things. And then our mayor at the time, who controls the Department of Education, put in a new chancellor who did not feel like Maker Ed was important. And so I moved to a school that did, and it has been really, really wonderful. I got to experiment. I get to experiment with my students, anything that I want to try, but I keep going back to wanting to make sure that I'm building projects that don't just, it's not busy work. It's using real tools with some real world applications. But because it's so diverse, we're doing 3D design, we're doing coding, we're doing circuitry, we're doing so diverse. Each project is so different, and you're teaching different tools. I came up with this idea that if I just use the design process as a framework for every project, and it works. I don't want to grade my students on whether or not their project is successful. I want to grade my students on whether my students go through the process of a project design, because sometimes it's going to fail.
It's
Um,
the journey, not the destination.
Exactly. So we have to, as educators, have something to document what they're doing. I mean, that's part of the engineering process. You're always documenting. So I developed the design process, and what I wanted to do today was to sort of start with how we think. When I teach the design process to my students, I like to start with something like this, a very simple design challenge. And if you guys want to give this one a whirl, you can. If I can read it, there we go. So this one's pretty simple. Basically, you have to design a way to get to the center of the building. There's a 4-story building that is 12 meters or 40 feet tall and has a courtyard with a center building. The center building is 4.5 or 15 feet from each of the walls of the main building. There's no staircase in the center building. Design a way to get to the top of the center building. So go ahead, go do that. If you want to think about it, you might already know this. I mean, this is some basic geometry, but and if you have any questions or if you need some more information, I'll give you guys exactly 3 minutes. No, I will not even give you that much. Just trying to get you guys, getting the students to think about what, it takes to design something. I'm just going to assume that you guys are thinking about how to solve this. So the first thing that when you're trying to solve this would be the design process. You're going through it automatically. I talk to my students about how it happens like that. They already have questions. They don't ask them. They jump in. They imagine what the answer is, and then they start to tinker with it. So if it were a physical thing, if I had given them the physical things, they would be tinkering with it without really slowing down their thinking. The design process, which is you first ask questions, then you imagine what your solution would be, then you plan to execute it, then you create it, then you test it, improve it, test and improve, you go back and forth with, and then you share out, look, I did this. So with that particular challenge, the first thing you're going to be asking is, what information do you need? I did not give you enough information to solve this intentionally, because again, I would want my students to be asking questions like, well, what materials do I have? Can I bring the stuff up the stairs? Can I bring a ladder? No, you can't. The stairs are too narrow. Like you have to use what's at the top on the roof of the larger building. So then the next question would be, well, what's on the top of the larger building? And there are two 15-foot planks of wood on the top of the building, and that's all. There's no rope, there's no glue, there are no nails, that's it. You can only use those two planks. So the students will start to think about it. I often get them to draw it. because I think it's one of those physical ones where you kind of need to see it. Um, and then you go from asking, so you know what materials you have, you know what space you have, you know what the lengths are. How might this turn out? You imagine it. Okay, I'm going to put two of them together and I'm going to slap it down, and okay, you no longer have those two pieces of wood because they fall to the bottom of the courtyard. So you have to really think about it more and plan. How can you make it real? You have an idea. You're gonna rip your shirt, lash it to the wood, put it down, and make that happen. Maybe that'll work, because the next thing you're going to do is make it, right? So you make what you're going to do, your first iteration. And if you're lucky enough not to be on the top of this building, you can test it and improve it all you want until you figure it out. The answer is a cantilever, right? You're doing the corner of the building so that you put a plank across the corner, and then you put another plank to the building in the center, and then you share out. But that's how, to get them to sort of slow down their thinking process, because again, it happens instantly. If I tell them I want them to design something, they just dive in. We do a lot in Tinkercad, and I need them to slow it down, because if they just dive in, they're not really giving it thought. They're not paying attention to what they're doing. They're just trying, which, the first time you teach a tool, you want that, right? You're like, I don't care what you make, just make something in Tinkercad. Use that tool, use this block, whatever you want to make it. But their design skills need to be honed and built up. So that's where using the design process as a framework comes into play. These are all projects that my students have done. We've made animations, we've made cardboard construction, we've done paper roller coasters, we do a lot in Tinkercad, we design video games, and we do some Arduino board circuitry. And I'm probably missing 100 other things that we do in between. But each one of those projects has to start with asking questions. So this is a slide deck that I give my students as sort of a guide. This is the very first time that I did it with my students, where I broke it down like that. And since then, I've reiterated my own approach to it. So, we go with this design challenge. You have to make a badge that lights up. If you're in America, kids go trick-or-treating on Halloween, and they go in dark places to get candy. It's not necessarily the safest thing to do. So, make a light that will shine, so that it doesn't matter. It's got to attach to your clothes, or you can wear it on your head, or something, you can wear it around your neck, but it has to be a badge that lights up. It has to emit light. So this project is to teach them the basics of Tinkercad. I don't just want to walk them through Tinkercad. I want to give them a goal. I want to give them a project. So this project, I also wanted them to work in teams. I wanted to teach them how to use Google Slides. I wanted to teach them how to do the design process. So for every project we do, if we break it down, we're teaching them a lot of different things and a lot of different skills. And that they're built into it, right? They couldn't have done this project if they didn't know how to sketch, or if they didn't know how to build in Tinkercad, if they didn't understand how to use, this was done on Jamboard, but we use slides now. So they have to know some things, and you're teaching them how to do things as well in those tools. When the students use this as a guide, they start with asking questions, and then I make them sketch them out, because you want them to understand, as they're learning Tinkercad, what the shapes are in a figure. It's a globe, it's a sphere, it's a square, it's a box. If they can draw it, they can make it in Tinkercad. And I tell them that all the time. They're like, can I just take a picture from somewhere else? And I'm like, no, you have to be able to sketch it. You have to understand what those shapes are in order to get your piece to look the way you want it to. If you don't know that the center part is a sphere, you're gonna throw things together. And like, again, slowing it down, imagining it, and then planning it, so that they talk a little bit about it, and then they make it. They're making it in Tinkercad. They're working in a team so that they get feedback from their team members as where test and improve comes in. They're showing each other their work and they're getting suggestions on how to make it better. And then we vote on the best of all the pieces. And then they make a presentation, and that's that share out. So this goes through the whole design process. In the end, they make that badge. And sometimes I print them, sometimes I don't. It's not the piece that matters. And sometimes my kids get like, oh, I really wanted that piece because I made it. I was like, do you want it because you want it and you're going to use it, or do you want it because you made it to be printed? And a lot of times they're like, well, I don't really need it. I'm not going to really use it. I go trick-or-treating, I have a flashlight. But they want it. And I tell them, I will print out something for you that you want to make, not something I tell you to make. So these are the things that I'm telling them to do. I want them to be inspired when we have one of our other projects is a Free Choice Friday project. I'm just going to flip through. This is another project which is using the design process, which is a chess set. Again, it's all Tinkercad, but it's all broken down for them to sort of really get them to think. They're supposed to design chess sets based on a book, movie, video game, or television show. And then they put this together. I have a student work here to just show you really quickly. One student decided that they wanted not to do a book, movie, or video game, but to do food, hot food versus sweet versus spicy. I was like, yep, go for it. And now they start making ideas, putting them together, trying to determine what piece goes to what. So they sketch them out. That's the plan. And then they go and they make them in Tinkercad. This is one of our longer projects. It takes a couple weeks, but in the end, they have a whole set of chess pieces based on their ideas. And then they get test and improve. They ask their classmates what they think of their pieces. And then I have them put them all together on a chessboard, and that's their share out. We do also print out a class set, which I'm not going to show you, but it's very cute. This is our Free Choice. This was a different iteration of the same concept, again, using the design process. This one is a Free Choice Friday project. So they get to pick from, it used to be anything they wanted, and that was too much. So now it's usually 3 or 4 projects they can pick from, or they can pitch their own project, whatever they want to make, but they have to fill out this slide deck. Again, I want them to make whatever they want to make. I want them to expand their own ideas, challenge themselves, be brave, and not be afraid that they're going to mess up their grade if they don't do well on a project. So I tell them always that it is this slide deck that they're getting graded on, nothing else. This was for holiday cards. They had to make a line of holiday cards for at least 5 different holidays. And then they had to get feedback. And I think this was, for me, the best way to do it. They had to get feedback from 3 different people, as opposed to just, one person looking at it going, it's okay, it's good. I wanted them to get grows and glows, so that they could turn around and improve their work from their classmates. So we're building a community of makers that, give feedback, that understand the concept of the design process from the beginning, from ask, imagine, plan, to create, and then to test and improve. And the feedback that they give each other becomes more precise. They know that it's going to just help. It's not meant to be judgmental or negative. It's meant to say, oh, well, your colors are a little bit off. Maybe consider, making them brighter, or for this student, I think her first iteration, she had everything was a Christmas card because it was around Christmas. So she had to go back and make all the different holiday cards because that was the assignment. And then there's a reflection, which, we want them to be thinking about what they're doing. And sorry, I'm in school, so the bells are going to go. We might get some announcements soon, but that's life. And then, I have a few other sets of slide decks that they're really just about the same. But again, the projects are vastly different. This is cardboard construction. My students made cardboard arcade games, but again, they had to go through the design process. And of course they had to, and they would, whether I had them slow it down or not, right? Because it happens so fast in an adult, and it happens really fast in a kid too, where that you make a cardboard arcade game and they're like, oh, I know what I want to make instantly, but then you have to get them to slow that down. You want to make a claw machine? Okay, out of cardboard? Okay, how are we going to grip? What are we going to use to grip? And then getting them to do that research, they got really sorry for the
Fiona Lou to
announcement.
the front door with your things.
Sorry. Then, getting them to do that deep dive into how do you make a gripping mechanism? How do you make the foosball tables? How do you make the foosball table work? They get so into making these games that they don't even realize they've spent the whole period and didn't do anything on their slide deck. So when they come back the next day, they have to now go back and do their slide deck, but they do it because they are happy to share out what they've made. And again, if you're looking at the rubric, it's just the slide deck and not the game, not how well they did it, but how well they did the slides. I don't know how many, I have paper roller coasters. And I decided that it was really a good idea for me to experiment on using the design process for class projects. I have an event coming up in 2 weeks. We're doing a board game jam where my students are going to build board games. We're hosting it. It's through Games for Change. Hasbro is going to be running the line of the competition. I'm talking really fast. I'm sorry. I'm trying to slow it down. But the Games for Change competition, I've been in it for years. Like every year we put stuff in. It's become international. It started locally, and when it was local or regional, I think it was just in the Northeast. My kids won. They won video game. They won prizes. They came in second or third. Ever since it went international, my kids have won nothing. And that's fine. That's because the level of the entries are so much higher. Making a board game or even a paper prototype of a board game is really complicated and takes a lot of time. So we're taking a whole day, and we're inviting students into the library, and we're going to build board games based on one of the 3 themes. And I decided to break down for myself, like, what are my questions if this is my project is this event. My questions are, what skills do I want to teach students? What skills do I want to reinforce in my students? Like, I want them to use Google tools. I want them to use Tinkercad. I want them to do some research, like all those things that I want them to do for this project. What tools can we use? I don't have a laser cutter. I not one that works anyway. But we do have Tinkercad. We do have a lot of cardboard. Back to supplies. What supplies are we going to need? We're going to need a lot. For a paper prototype, you want to have everything the kid could possibly want to use available to them. And then how long do I think it's going to take? And will this be independent or group work? Right. So that's how I was these were the questions that I was asking. And then if I go from ask to imagine, I have to answer those questions. So I imagine, I know that I want my students to understand how to make an educational board game, not just a board game. We're not playing Trouble. We're doing it to educate people. I specifically wanted one theme, and that is the road safety theme, because one of our students, when my first year here, one of my 7th graders died in a car accident. He was hit by a car, and he was a maker, and it hurts still to think that he's not with us to make a board game. But getting kids to think about the dangers, they're going to be driving. They have to be thinking about, the safety. Like, there's a lot that they can teach or learn through a game. So I want to make sure that they're not just making one of my kids said, I'll just make Monopoly with cars. I'm like, that's not teaching anything. So some of the things I need them to be able to do: graphic design, how to share workspaces, writing directions and rules, but also how to do research. I have the librarian is helping us gather content and research. And then the supplies and all those things that I'm going to need for it. At this point, I've just gotten to the point where we're recruiting students to get into teams. So I don't have my create, test and improve or share, but when I do, I will finish this out. But it worked for me to help. It helps me sort of frame for myself what I'm doing and why. So if anybody asks me, why are we building board games? I'll be like, well, we're learning a lot of different things through doing this. And that's it. That was my whole using the framework as a tool, design framework. So I don't know how much time we have, but I would love to answer questions.
We have about 20 minutes.
20 minutes. So let's answer some questions. I mean, we can talk about some of the projects that my kids have done. And I'm going to put this here. You can reach me, by the way, at that email address. Any questions?
Question. Can you hear me?
Yeah.
So I know you said some of your projects took like a span of weeks, but I wanted to know what was like your quickest project with the kids?
I think this year, my students all got Chromebooks, so it's a one-on-one school. And this is the second year that they all had it. Last year was a disaster because the chargers and the Chromebooks all look the same. So we never knew whose was whose. And we were told they're not allowed to put stickers on their Chromebooks or their chargers. But I managed to talk the admin into letting us do that. So we took a period, it was like 2 periods, to design name labels. So they made logos with their names, and then I printed those out and they put them on their Chromebooks and their chargers. And that was, they had to design it. It had to represent them. They had to pick the font. They had to pick the size and shape. So there were a couple of choices. It wasn't a very deep project, but that was definitely a quick one. And we made them on Canva. But again, it's you think about, make a name label. It's very quick. You've already done it, right? You already know kind of what you want, but break that down and, ask the question, well, how big can it be? Can I use color? Is it color or black and white? So all those things become, again, that design process that we don't document enough. And we do it so quickly that we don't, especially creatives, and I assume everybody here is a creative, we do it so fast that we don't even realize we're doing it before we're making. So, I have a lot of kids that they come to me and they want to be told what to do and how to do it and what exactly and where it goes. And I don't want that. I want them to have their own ideas. And sometimes they find it a little disturbing. It's hard for them to come up with, like, the Free Choice Friday project, which was only on Fridays for about a month. And so 4 Fridays, because I see them every day. So for 4 Fridays, we do Free Choice Friday. And the first time I did it, I said, you could do anything you want. If you want to make, fabric art, if you want to do 3D design, if you want to make a game, if you want to do cardboard construction. And they just sort of, there wasn't as much buy-in. I don't know what to do. A lot of that. When I limited the number of choices, the last round we did, we had holiday cards. They made tiny toys in Tinkercad, which we gave out at our holiday party. And they were itty bitty, really, really cute. But they also had to document everything that they were doing in that slide deck, because honestly, a lot of kids did the tiny toys and a lot of the tiny toys were fails because they couldn't be printed because they were too small, or the fails that we get with Tinkercad and 3D printing. But that doesn't matter, right? You're not going to get a lousy grade if your print doesn't work. You're only going to get a lousy grade if you don't fill out your slide deck. So I find it very helpful for me to generate grades as well, because of course I have to grade everything. And I was an English teacher before I was a tech teacher. And so when I get my slide decks back from my kids and they don't capitalize the word I and they don't write full sentences, that's where my English teacher comes right out. I'm like, this is going online. You're putting this out into the world. If you do not capitalize that word I, you lose a point. And I will go through and take 10 points, 15 points off. And I said, you can get them back by fixing it. Like back to that share, test and improve, test and improve. They do that. It's just they want to do it so quickly, or they want to be told what to do. When it's a longer project, it is kind of hard to, especially the Free Choice Friday, because it's, one day and then a week and then a day, and, pulling that across can be really hard. Again, this year I limited it to 3 projects, or 4. You could pitch one. Like if you have an idea, yeah, let's hear it, and I'll support it. But I'm not going. You can make jewelry. You can make a stuffed animal. You could no 3, and it's gone well. I like that a lot.
Lori, I came in a little later, so maybe you covered this, but how does what you do fit into the whole? Well, it's a middle school, right? So how do you get the other teachers to do, you're doing a spectacular job. How do you get them to follow that in the later grades or earlier grades? How does it all fit together?
Well, this is a 7 to 12, which is actually really cool to see my kids going into high school. My first year now, the first year teaching here are now 11th graders. And I've heard from teachers that they can tell the kids I've had because they come in with the design process in their heads, which hearing that was awesome to hear. The teachers have been being pushed to do more project-based learning. So they've been being more outgoing in that regard. We've got a lot of 3D printers in our school, but I think for the most part, they're still really chained to their curriculum calendars. So projects kind of throw them. But when they get a kid who they don't have to teach them how to be creative. They don't have to teach them how to use Tinkercad. They don't have to teach them how to make something or build something. We did cardboard construction. One of our science project kids made a giant paper roller coaster based on the paper roller coaster that we had done in 7th grade. So the kids are carrying it through, and the teachers, I think, are giving them opportunities. And if a teacher asks for support, we just did a PS I Love You Day, which out on Long Island is a suicide prevention event, and we made pins. The students design pins in Tinkercad, and then the art teacher has them painted, and so it becomes this whole multi-grade school-wide project. So that's those are some of the things. Plus, again, the kids get excited about making and doing, and they show the teachers